Hi, Tana. So you're right that we did factoring for limits that would be of an indeterminate form. So indeterminate meaning if it says x goes to 3 and we try to sub in a 3, we're going to get the square root of 6 minus 5, square root of 1 minus 1. That's going to give us a 0 in the numerator. And then if I sub in a 3 in the denominator, this is what's called the indeterminate form. You get 0 over 0 or infinity over infinity. And there's no factoring that you can do because it's not polynomial. It's not like x squared. So an alternative to factoring is to multiply by the conjugate. So you can either multiply by x plus 3. It's this term and then the opposite of the second term. But more commonly, it's going to be the conjugate of the square root. And you have to multiply by the same thing in the numerator and the denominator. So the conjugate would be this term, well, this thing, and then the opposite of that, so plus 1 in the numerator and the denominator. And if you remember the difference of two squares, what that's going to do is these two multiplied together are the root is going to cancel. The inner term, if you were to multiply these out, they'd be opposites. And then minus 1 in the numerator. In the denominator, it didn't get any prettier. It just got a little more complicated, actually. But just go ahead and write out everything that you have in the denominator. Usually what happens, as you could tell if it's like a good first step or not, is as I'm showing this in the denominator, I see that there is some simplification that I can do in the numerator, and this happens to be 2x minus 6. Now there's some factoring that I can do. There's a common term of 2, common factor of 2, and then I see now that this term x minus 3, this not term, but this factor x minus 3 is common in the numerator and the denominator. So I would like to now take the limit as x goes to 3 of this new form after I factored that out. But I didn't see that common factor until I multiplied by the conjugate of the expression that had the square root in it. So now I have in my numerator solely this 2 here. And then in my denominator, I'm going to have this mess, the square root of 2x minus 5 plus 1. Now, if I do sub in the 3, I'm no longer going to get a 0 because it's not the root minus 1, it's the root plus 1. So at this point, I now can sub in the 3. I'll get the square root of 1 plus 1 in the denominator. That'll actually end up being 2 over 2. And this limit exists, and the limit is equal to 1.